Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 11th. Looking at significant wave heights for the North Pacific Ocean, we actually see some activity. Yes, there are seas 22 feet in the northwestern Gulf of Alaska, and they are forecast to build, aimed somewhat at Hawaii and better at the U.S. West Coast. And there's even some hints of other activity starting to develop in the far West Pacific. Maybe we've turned the corner. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough that is a dip in the northern branch of the jet stream pushing south. Just like that right there. Not a great trough, but any trough is good given where we've been lately. This trough, the jet is consolidated, pushing off Japan, but then it quickly splits, with the northern branch pushing up towards Kamchatka, and then falling south into the trough we were just talking about, with winds to 140 knots. This helps support a counterclockwise flow aloft, and down at the ocean surface, that is the hallmark of low pressure, and low pressure, of course, generates wind, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, of course, makes surf. So we have something of interest finally. Of course, the southern branch just sort of is meandering along rather weakly here, down around 27 degrees north. But they join forces right here in the northwestern Gulf of Alaska. That's why we have this wind energy here. And then just as quickly as they come together, they split apart, with the southern branch pushing over Baja and the northern branch racing north up into Canada. And when you get this split sort of pattern here, you end up with high pressure in between, and that, of course, does not support the production of swell. So high pressure probably there, high pressure probably there, but low pressure there. All right. Let's go put this in motion, see what's going to happen. There we go. Winds build up to 150 knots tonight, probably like 6 hours from now, supporting gale development in the Gulf, and then continuing but weakening as we move into Monday and Tuesday, and the low is expected to probably push into Canada just looking at this. High pressure reigns supreme off the California coast. Now we look, here's another, sort of a trough trying to develop in the western Gulf on Wednesday. Bit of a split, kind of a muddled pattern. Let's see where this goes. Yes, another trough forecast as we get Wednesday afternoon in the western Gulf. Same sort of deal. Also, almost a trough trying to develop off Japan. The jet looking a little more consolidated, but nothing super impressive. Now that trough, that's pretty pinched off there as we get into Thursday. Split underneath it. You know, maybe some hope for gale development there, and then that kind of peters out as we get into Saturday. But look at this. As we get into next weekend, winds start building, actually looking decent over the West Pacific, if you are to believe the models. And let's just roll this out a little bit more. Here we go. Decent consolidated jet with winds 140 knots pushing off Japan as we get into a week from now, Sunday. Now still split and pretty muddled, but also look at this, almost a little trough, kind of something trying to set up off California a week from now too. All this smells suspiciously like perhaps the inactive phase of the MJO is moving out of the Pacific, and maybe the active phase is to start developing in the far West Pacific. But we need more details before we can actually make that proclamation. And of course, never believe a model a week into the future. All right, so let's go take a look down at the ocean surface, see what's going on. As expected, low pressure is developing in the Gulf of Alaska with a decent fetch of 30 to 35 knot winds. Now, that's not very impressive by any stretch of the imagination, but given how there is virtually nothing going on in the Pacific at this moment other than this, we'll take it. This certainly could produce like 12-second period swell. Mainly for Hawaii, maybe a little bit the U.S. West Coast, but let's see what's going to happen. Here we go. As we get into Monday, 35 knot winds over a little bit broader area, and sort of continuing in pockets, 30 to 35 knots. Notice another little secondary low trying to develop Tuesday morning, pushing over the date line. Does it do anything? Yes, actually produces a tiny area of 45 knot winds aimed at Hawaii Tuesday night into Wednesday, and then sweeping east into Thursday and fading out. Oh, no, actually not. Still together on Friday. Not a big system by any stretch of the imagination. And then here comes another system. Forecast developing over the dateline on Friday night. 35-knot winds out of the northwest, building to almost 40 knots. And there we go. Decent solid fetch of 40-knot winds. Saturday night, just east of the dateline, moving towards the Gulf of Alaska, and then fading out some. So, actually, there's some hope. Let's go take a look at the effect of these winds on the ocean surface. So as we mentioned before, here we go, 22-foot seas over a kind of broadish, ill-formed area in the western Gulf of Alaska right now from that developing low that's sitting right here. Let's put this into motion, see what's happening. There we go, 25-foot seas. Yep, 25.6 feet at the peak right there is forecast Monday morning. That's good for probably a 14-second period swell pushing into Hawaii and the U.S. West Coast. Nothing huge. And then that fetch and seas sweep east into Tuesday morning, sort of fading out a little bit, but still 4-foot seas or so pushing east. Now, most of this whole thing up in here is shadowed relative to San Francisco, but some of the earlier fetch was south of the line and unshadowed relative to San Francisco. Anyway, secondary fetch develops. Here we go, 23-foot seas or so, building to 26-foot, 27-foot. That's good for swell into Hawaii, and this is on like Wednesday, Thursday, the gales to develop, so maybe swell a day or so later. And that sort of meanders its way through the Gulf. Now, not a big fetch area, but still, just sort of steady uptick of swell is possible if all this comes into pass. And then here's our next gale developing just west of the dateline Friday evening. What is that, 24-foot seas, building to 28 feet or 27 feet. There's 28 feet, a little bit far to the north on Sunday. Oh, to 30 feet. So this is definitely an upgrade from previous runs of the model. But again, a week out, not believable. But it gives us some hope. And where do we go? We get it right there, moving into the Gulf on Sunday night a week from now with 26-foot seas over a decent-sized area. This is good. This actually kind of looks like the sort of pattern you get in early October. And here we are, second week of November. So at this point, I'd say we're still about 6 weeks behind normal. This is not particularly uncommon when you're coming off of 2 years of La Nina. Typically, the seasons get kind of out of whack, and you lose about 6 weeks out of it. So maybe we will eke out some sort of a year, but for the most part, we've lost the first 6 weeks of fall. If this pattern even remotely develops like it suggested, though, at least we'll be in the ball game again. So then the next question is, what about rainfall into California? Well, let's talk about that a little bit. So we're jumping ahead here because there's high pressure locked over the coast, no real winds, no real wind swell till we get into like Thursday or so, and what we're looking is this forecast low pressure system developing in the Gulf of Alaska. See, here's this high pressure split jet stream over here, but watch this low. It's very weak, very marginal at best, but here it is at 180 hours out, just off of San Francisco on Sunday night a week from now. Now, that's not much of a low, and it's certainly a reach believing any model this far out, but it gives us some hope. Let's do a quick look at the rainfall models. And here we are, Friday. Here's that low. You see the blues, and there's the front. The blues are light rain. Here's the front associated with that low. We'll just sort of put this in motion. You can sort of figure it out as it gets closer. And where are we? There is at 180 hours, a very, very weak area of moisture right off the California coast. The question is, will it make it inland? Will this even develop at all? Hard to say, but at least there's something on the charts that's teasing and supposedly getting close. So maybe there is some hope. All right, so let's go take a look a little bit longer term, more than a week out. Let's see what's going on with the MJO, because the Madden-Julian oscillation certainly is the major influencer on weather, over the next couple of weeks. And then beyond that, what's going on with potentially El Nino and the Southern Oscillation. So first up, the MJO. We'd like to look at surface winds across the equator in the Pacific. East Pacific here, West Pacific here. Typically, we're just looking at the arrows. This is from the TAO buoy array, series of buoys strung across the equator, used mainly for monitoring El Nino, but you can also get some sense of what's going on with the MJO. We see easterly winds, trades blowing pretty strong from the East Pacific to just about to the dateline, and then they get weak. And then notice actual westerly winds once you get to about 170 east or so. The Kelvin wave generation area, 5 degrees north to south from 170 west, right in that box right there. That's New Guinea there. So we're way in the far west Pacific too, just a little bit over the dateline. When you get westerly winds in here, or westerly anomalies, and they blow long enough and strong enough, you can actually get a Kelvin wave. That is, warm water that's here starts moving to the east. But when you also see these westerly winds, that's a sign of the active phase of the MJO. So, are these winds stronger or weaker than normal for this time of year? We look at anomalies, differences from normal for this time of year. All these easterly winds, that's pretty typical. The arrows are not going east or west. They're just kind of neutral, meaning, yeah, that's normal. But once you get, again, to this little area where the wind starts slacking off, you see right here, all of a sudden you see westerly arrows, westerly anomalies. That's a pretty good sign of the active phase of the MJO, and that's exactly what we want, because the active phase of the MJO, one, not only can, if it's strong enough and long enough, can help produce a Kelvin wave, and that's a precursor to El Nino. It also starts imparting energy to the jet stream, and when you have a strong jet stream, then you start getting troughs, you start getting gales, and then you start getting surf. So, remember, we were talking a week out, we saw the jet stream and was building in the far west Pacific. Well, all this these westerly anomalies suggest that the active phase of the MJO is building and fueling the jet stream, so it makes sense. Let's dig deeper. Wind anomalies. Let's look at this. 850 millibar wind anomalies. It's up about 4,700 feet, but a good proxy for what's going on at the surface. South America, Mexico, New Guinea right there, the equator right there, dateline right there. Kelvin wave generation area. In your mind, draw a box like from here around here, and we're looking for arrows blowing from the west, oranges and yellows, and you see kind of a mixed pattern. This was November 5th. We just go day by day, sort of inspect this area. What we see is building westerly anomalies starting the 8th of November, and a little bit more on the dateline and into the Kelvin wave generation area, 5 degrees north and south. So draw your box right there, and they go, oh, this looks like maybe, just maybe, the active phase of the MJO is starting to materialize. And then zonal wind anomalies. Okay, this is the forecast, but it's also what's been happening in the past month. Okay, this is the whole planet on one chart. Dateline goes right down the middle. That's 180 degrees. Kelvin wave generation area, basically between these two tick marks. When you see blue, that's easterly anomalies. When you see reds, that's westerly anomalies. So we just go down here. We had a good westerly wind burst here in late October, but didn't quite, maybe almost November 1st, and then we had easterly anomalies in the Kelvin wave generation area. This is that the jet stream fell apart. This is a good sign of the inactive phase of the MJO. But here's the forecast starting today, and you see, what do we see in the Kelvin wave generation area? Right between these two tick marks going up. Here's our westerly anomalies building on the date line, them building almost the whole way over the entire Kelvin wave generation area, and forecast to continue for the next week. Yes, easterly anomalies on the date line, but there's enough energy here to make us at least begin to hope to believe that the active phase of the MJO is materializing, and that would in turn be imparting energy to the jet stream, and that's why the GFS model was showing a stronger jet stream over the West Pacific a week out. All this makes sense and is coherent. All right, let's go out a little bit further. 2 weeks. All right, outgoing long wave radiation. We don't have something 2 weeks that gives us wind, but we can sort of infer it using outgoing long wave radiation. What's that mean? It's basically the amount of sunlight reflected off the ocean surface. When you see these yellows and oranges, that means, see the positive numbers? More sunlight reflectivity. That means no cloud cover. That means high pressure, and that is typical of the inactive phase of the MJO. You see blues here, that means less sunlight reflectivity, more clouds, low pressure. That's the active phase of the MJO. So basically, the inactive phase of the MJO is on the date line, probably moving east, while the active phase of the MJO is in the Indian Ocean, moving over the maritime continent, it too moving east. So here we go. We look 5 days from now, active phase is building in the West Pacific as the inactive phase moves east, building more, this per the statistical model, as we get 6 to 10 days out and 2 weeks out. A good, healthy, active phase is to be setting up in the West Pacific. That would certainly fuel the jet stream and gale development, while the inactive phase builds in the Indian Ocean. But then we look at the GEFS model, GFS ensemble model. It's not nearly as optimistic as the statistical model. Yes, the active phase makes it to the West Pacific, but then instead of blossoming like it does here in the statistical model, it just kind of withers and dies, and the inactive phase moves quicker into the West Pacific. So a little bit of discrepancy on the 2-week run, but certainly for the next week or so, it looks positive with the active phase moving towards the West Pacific. So yet another 2-week view here. So this is phase diagram charts, another way of tracking the active phase of the MJO and its strength and its position. So assume you're looking down on the North Pole. The active phase travels from west to east, as does the inactive phase, from the Indian Ocean over the maritime continent into the West Pacific, over the dateline, under the United States, across the Atlantic, and then over North Africa back to the Indian Ocean. The heavy dot is where the active phase is right now. So in the East Indian Ocean, making its way to the maritime continent, and the further the dot is away from the circle, the stronger it is. If it would be way out here, it would be exceedingly strong. This is we'll say a weak to modest active phase of the MJO. Per this, the ECMF model, it's in about 1, 2, 3, 4, 5 days. It's supposed to make it into the far West Pacific and then rapidly just weaken and limp its way into the West Pacific 2 weeks out. The GEFS model basically suggesting exactly the same thing. So not any indication of a strong active phase. Now here's the deal. If you have El Nino developing in the Pacific Ocean, it would not be unexpected that both the active and the inactive phase are extremely weak over the Pacific Ocean. So that would be basically from this area over into probably around here. So this may be a sign of El Nino stomping on the MJO, or it may just be a sign of a weak active phase of the MJO and not good for storm production. Too early to tell. And yet another model, a 40-day upper level model. The greens in this chart, there's there's New Guinea, there's South America, Mexico, Philippines, equator right there, dateline roughly there. So the greens are areas favorable for precipitation, and one could assume that to be the active phase of the MJO. And this is, of course, today. So you just see the active phase of the MJO forecast to traverse the Pacific through, move into Central America, probably somewhere around December 5th. Okay, so that sort of means the whole second half of November should be favorable for storm development. Then we have the inactive phase, but it looks pretty weak too, and it's supposed to meander from the West Pacific, starting maybe Thanksgiving, and meander into Central America into about Christmas, and about starting mid-December, the active phase then also starts developing in the West Pacific. So what's this mean? Well, maybe some support for storm development from now for the next 2 weeks, let's say, and then maybe 2 weeks of not such a great pattern, and then starting about mid-December, another beginning of 2 weeks of potential storm development and swell development. Let's take a look at the CFS model. Okay, same sort of deal. Whole planet on one chart. Kelvin wave generation area between these two tick marks here. This is what's happened in the past. You see all this red and you go, what's going on here? Well, what that means is there's been a lot of westerly wind bursts, and not necessarily associated with the active phase of the MJO, the black circles of the active phase of the MJO, but still some not associated with that. And that's why there's all this discussion around El Nino, because a lot of westerly anomalies. So where are we right now? Well, here's the current forecast. This is the dotted black line is the inactive phase of the MJO. It's fading. This is supposedly the active phase of the MJO building as we get into, what are these, 7 days out, so November 17th, so probably November 15th or so. And the reds are westerly anomalies, very strong westerly anomalies, but you really want them in the Kelvin wave generation area, right around in here. So it looks like the 7th through the 24th, even almost to the end of November, pretty favorable for storm development, maybe even some precipitation, and certainly swell development. And yet, an even longer version, 3 months out from the CFS model, 850 millibar wind anomalies, same deal. Those are winds up about 4,700 feet. The yellows and the oranges are westerly anomalies. That's what we want. Kelvin wave generation area between these two tick marks right here, heading up. Now, this is past activity here. You see a pretty good amount of westerly wind anomalies. And then the forecast says steady westerly winds slowly moving off to the east in the Kelvin wave generation area nonstop from now through the end of January, and then things sort of breaking up a little bit. Let's overlay the MJO. Is there an MJO? Well, so this model says, active phase of the MJO in starting in the Kelvin wave generation area on about 5 days or so, continuing through the end of the month. Then a week in active phase, but westerly anomalies continuing, and even pretty strong at one point here as we get into December and January, but then no real coherent MJO signal, just sort of a mixed bag. Now let's overlay the low pass filter here, and what do we have? So the solid contour, all in the Kelvin wave generation area, is the area, we call it a low pressure bias, the dotted contour, high pressure bias. So what this says, high pressure in the Indian Ocean and low pressure over the Pacific Ocean. This is pretty typical of what one would call El Nino. Is it El Nino? Not yet. It's not really looking like it, but maybe, just maybe, as we get into the winter season, we'll get something that at least resembles a weak El Nino pattern, something to sort of push the storm track along a little bit better. So what's going on in the ocean? If we're going to now start talking about El Nino, well, there's an ocean component to El Nino, right? So this is TAO array buoy data, West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys on the equator, and the X's are the sensors on those anchor lines. So you get, if you look at all that data, you can sort of see warmer than normal water, 30 degrees Celsius from the date line. Moving from the West Pacific to the date line, this had actually moved back to somewhere around 175 or even 170 in the past week or two, moving to 180. The 24-degree isotherm line had retrograded to like 160 or maybe even back a little bit more than that. Now on the move to 155, 156 west, and the 20-degree isotherm line pushing into, I'm sorry, this is the 24-degree isotherm line, that's the 24-degree isotherm line pushing into Ecuador, suggesting warm water is on the move to the east. But it's not so much the actual water temperatures that matter, it's the differences from normal for this time of year. And you look at this, again, East Pacific here, West Pacific here, we see a lot of warm water, very warm water, 5 degrees above normal off the coast of Ecuador here. This all looks good. So this is what is known as a Kelvin wave. That is, you get westerly anomalies blowing in the Kelvin wave generation area, driven by the active phase of the MJO, and it takes some of that warm water, remember, see all that warm water there? Starts pushing it to the east, and then that water sort of forms a bubble or a stream, and it all just pushes east, and that is a Kelvin wave. If you get successive Kelvin waves and enough warm water buildup in the East Pacific, the trades start picking it, blowing it along the surface back to the west, and that's what helps get you El Nino. That is a warm water slick on the ocean surface in the East Pacific off Peru. So this is actually the second significant Kelvin wave so far this year. But what we also see here is it's moving onshore, but there's warm water behind it, but not another Kelvin wave yet in development. We need a good, strong, active phase of the MJO to take warm water that's here and give us Kelvin wave number 3. The question is, will that happen? Too early to know. Here's a higher res model of the same sort of data. Clearly you can see, well, we'll count them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5 degree above normal water temperatures. That's 5 degrees Celsius. That's pretty darn warm on the move from the east into Ecuador. Exactly what you would want if you have a developing El Nino. But you also see that once you get to the dateline, this Kelvin wave, that's pretty much it. Now, there was, see this blue here? It was actually sort of a broader area of blue here 2 weeks ago. The good news is that stopped. And we think some more warm water starting to seep into the West Pacific. It actually comes dribbling in from the maritime continent over top of, just north of New Guinea, and then building in this area, and then eventually starts moving off to the east. So we're not thinking this is the start of another Kelvin wave, but it's not a complete cutoff of the cycle either. The more warm water you can get moving east, the better your odds for El Nino. Sea level anomalies. Okay, so this is kind of hard to read, but here's South America. Here's Mexico here. All right, there's New Guinea there, Australia. So what you typically get, here's the Philippines. This gap right in here, if you get westerly winds blowing in there, it'll take warm water here, start pushing it over north of New Guinea, and start building up in this area, right? So this is not surface temperatures, though. This is height anomalies. Okay, that is, you strip out, this is from the Jason-2 satellite, strip out all the waves, strip out the wind waves, strip out the tides. What you see is 5-centimeter bump in the ocean surface. Actually, it covers the entire equator. That's a pretty good sign of some sort of El Nino trying to develop, and up to 10 centimeters here. So what this means is warm water, of course, expands. The warmer the water, the higher the bump on the ocean surface. So all it's saying is there's a bunch of warm water spread all the way across the equator. The peak of it's right here, basically south of California, and working its way off to the east. More indications of something like El Nino trying to develop. And then put in historical context. Here's the entire Pacific Ocean, West Pacific here, East Pacific here. This is back in December of last year. Cool waters, La Nina, off of Peru and south of California. And then in January of this year, tiny little Kelvin wave. Now see, just barely any warm anomalies, and then it dissipated. It didn't really do much, but it kind of killed La Nina. But the atmosphere doesn't know it yet. It still thinks La Nina is going on. As we got into February, upwelling phase of the Kelvin wave cycle, and then a big westerly wind burst started taking warm water, pushing it off to the east, and it moved into Ecuador in July. Multiple months to make it the whole way across the Pacific into Ecuador. And now another big westerly wind burst developed this fall in the September timeframe. This is our existing Kelvin wave, still trying to make its way across the Pacific, but poised and we believe erupting now, has been for several weeks, and will probably continue for another month or so. Now the question is that warm water actually erupting to the surface? And does the atmosphere respond to it? If you have warm enough water on the ocean surface in the East Pacific, well, anywhere for that matter, you start getting evaporation. The evaporation works its way up into the upper atmosphere. That helps start fueling the jet stream. If the jet stream wakes up, then you start getting storm development. And that's what why all the concern or excitement around El Nino in the North Pacific in the winter months in terms of storm production, because it's really warming the ocean surface and fueling the jet stream in the East Pacific, which is typically much colder than normal, or much colder than this. So let's just cut to the meat of the matter. What's happening at the ocean surface? Well, here is Ecuador, Peru, and Central America. And this is sea surface temperature anomalies, differences from normal for this time of year. Reds are warmer than normal, greens and blues cooler than normal. So do we have El Nino? Well, there's the Galapagos. Typically, if you have El Nino, you're going to see warmer than normal temperatures around in here. The official El Nino monitoring region is from 120 west out to 170 west. But it typically normally starts all around in here. This is where the Kelvin waves erupt right off the coast of Ecuador, and then the trades start carrying the warm water from those Kelvin waves off to the west into the Nino 3.4 monitoring region. Again, right in this area right here. So, yes, we see warmer than normal temperatures, but they're not huge. I mean, you get a super El Nino, you would see like this big triangle that goes from here down to here, up to here. We're not seeing that. We see, yeah, I mean, there's actually cooler than normal temperatures well off the coast of Peru. Yeah, some warming near shore, but certainly no clear signal of any strong El Nino here. This is a very, very weak El Nino at best. But it's trying to get its act together. We know there's more warm water in the pipe. It's trying to erupt here. But, you know, this has been a very slow-moving eruption, and this is the second Kelvin wave, and the first one really didn't do much, and the second one's doing better, but still not getting much traction on the ocean surface, unfortunately. 7-day trend, sea surface temperature 7-day trend. The oranges and yellows are where the trend is warming. We see that off Ecuador, along the Galapagos in this area. But out further here, if anything, I see little pockets of cooling in the Nino 3.4 region. Again, 120 west to 170. Nothing too significant. And warming, yes, along Central American coast and a little bit along Peru, but, you know, no real stark signal that some major heat eruption is going on in this area. And finally, let's just back it off and get the good old overview. Okay, if you're going to have a big El Nino, we said warm water from like here, out to here, down to here. You know, no, not seeing it. I see cooler water there. Along the equator, yes, it's warm, and it actually looks better than last week, and it looks better than the week before that, but it's still, you know, not some stark, significant, you know, obvious signal, just kind of muddling along. So what's going on? Well, the guess is perhaps that the atmosphere is still La Nina, okay? We've had 2 years of La Nina, and it's just not going to turn on a dime. It's going to take a good push in the ocean of warm temperatures to really get the atmosphere to respond, because the atmosphere just doesn't respond here. The global weather, the pattern over the entire planet has to change, and it has to be driven by these warm waters here. And the warm water signature is just not that strong. It doesn't have enough. One, it's not hot enough. It's not broad enough. You know, yes, it's going to have some effect, but effectively, right now the atmosphere is acting like we're just in a normal kind of year. Sea surface temperatures in the Nino 1.2 region. This is the area right there along Ecuador, Peru, the Galapagos. You can see how temperatures in August, September were below normal, typical of La Nina. And the trend is, sort of look at this, you go, yeah, it's warming, but not much. I mean, the current value is 0.422, and that's kind of on the high side. You know, in this region, it's, you know, basically neutral, give or take 0.2 of a degree. Not too impressive. Now, in the official Nino 3.4 region, again, that region sort of out more in the middle of the Pacific, you can see the trend. The latest value is 0.540, so half a degree above normal. And you can see we were up to 1.5 degrees above normal. What was that? Maybe a week ago or so, something like that, 6 days ago. But that was a spike. We didn't really expect that was going to hold. But you kind of look here, we were hovering around neutral in August and September. Then late September, we started warming. We're about averaging, just eyeballing it here, half a degree to maybe 0.6 of a degree above normal, something like that, maybe a little bit more. All right, so we've talked about the MJO. We've talked about Kelvin waves and subsurface sea temperatures. We've talked about surface sea temperatures. And now we've been talking about the interaction of the atmosphere and those sea surface temperatures. So we have some two indices here that we can use to measure what's the atmosphere doing? Is it sensing warm water in the Pacific on the equator? And is it doing something to move towards an El Nino configuration? Well, as of November 11th, so we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If the index is negative for a long enough period of time, you're said to be in the active phase of the MJO. And if it continues even longer and gets deeper, then you're in El Nino. You need negative numbers. Today's value, plus 11.2. And you just sort of go back the past month and look, and positive, not really negative at all. The 30-day average, it sort of strips the noise out of it. 4.80, still positive. And let's just go back for the past month. We were actually closer to El Nino in October, you can see here, than we are today. And then the 90-day average, same deal. Today's value is minus 1.96, so basically that's neutral. You go back to the early part or mid-October, we were at minus 4 or so. And there we are, minus 4.66. But now we're up to minus 1.96. I mean, a lot of this is attributable to we've been in the inactive phase of the MJO the past couple of weeks, so the numbers are high. We expect these to start falling as the active phase builds, but it needs to build and hold for a couple of weeks to really help push the average down. But we're nowhere near El Nino territory at this juncture in time. So what this really says is, yeah, there's warm water in the Pacific, but according to this index, the atmosphere doesn't sense that anything particularly unusual is going on because the area of warm water isn't large enough and it hadn't been there long enough. And then there's the ESPI index, pretty much like the Southern Oscillation Index. Instead of measuring difference in pressure between the area north of Tahiti and the area north of Tahiti and the area north of Darwin, Australia, it's amount of rainfall. Is there more or less rainfall than normal, specifically in this region? If the index is negative, it means it's drier than normal. If it's positive, it means it's wetter than normal. So we certainly want to see a positive index. And what's today's value? Minus 0.24. Not good. It's not very negative. It's just barely under 0. And actually, last week, I think we were down at minus 0.3, and I think we went to minus 0.35 or 0.36 a couple of days ago. So it's kind of coming up. But basically, all it's saying is, kind of business as usual. Nothing, no big show here. Don't look this way. There's nothing going on. Oh, and here's the trend for the Southern Oscillation Index. Today, here's our value, like whatever it was, 0.4 or something, 0.35, something like that. But you can look at the trend. So back all of 2018, basically, if you average this out, and you can see this is the active phase of the MJO, the inactive phase. And what seems to be prevalent in the January time frame? Inactive phase of the MJO. Now, yes, we are going down somewhat, moving into negative territory, but nothing strong. And if you kind of look at the long haul here, even starting July 2016, we've been positive. This is all La Nina. So this is when we say the atmosphere is primed for La Nina. It's just that pattern's dug in. That's because that's where we've been. And it's going to take, so here was our last El Nino in January 2016, December 2015. You see we're down here at this is the 30-day average, down at minus 15, minus 20. At one point, some readings to minus 23. We're nowhere near that. This all, basically, we're hovering, if you're plus 5 to minus 5 and hanging in this area, then you're just ENSO neutral. No El Nino, not La Nina either. And then in reference to the ESPI, so again, that area where they're monitoring precipitation, right in here, there's South America, there's Mexico, there's the date line, there's the equator. So this box right here, if we saw blues in here, that would say, let's see, outgoing long wave radiation. That if we saw blues in here, that would mean a bunch of clouds in this area. That would mean higher than normal temperatures and precipitation. That would suggest maybe El Nino. We're not seeing that. We're not seeing yellows, which is good. 5 degrees north and south is like just right there. So it's just basically neutral. The atmosphere is not doing anything. Even though the surface temperatures are warmer here, they haven't been warm enough, long enough, or warm enough, or over a broad enough area to really get the atmosphere to respond. So then finally, the forecast for temperatures in the Nino 3.4 region, the official El Nino monitoring region. Where are we? Almost middle of November. Supposedly temperatures are supposed to be 1 degree above normal. We're not close to that. We're half a degree. We're down here. This model, of course, appears to be way overhyped. We're not buying any of this. Yeah, maybe we'll get 0.7 of a degree as we get into January, February. But the model does say, at least it doesn't say negative temperatures like what actually happened back, this past year, La Nina. So the trend is favorable, warmer, but not as warm as what the model suggests. Yeah, we're supposed to be at 1 degree above normal and supposed to stay there at 1 to 1.2 degrees above normal the whole way into July. That's probably not going to happen. Half a degree, maybe 0.7 as we get into the spring, and that's, you have to be at half a degree or warmer for 5 months before they declare El Nino. Typically, if that were going to start happening, it would have happened in June or July, and that wouldn't even be a super El Nino. That would just be sort of for a good solid El Nino. But what are we, 0.45 degrees today? So we're down around here. We're still not really even in El Nino territory yet. 5 months from now, yeah, maybe they'll declare El Nino in April or May, but by then it's too late and it's over, and the atmosphere will only start responding then. Now, part 2 of this, though, is maybe this whole winter is just going to be about trying to unlodge La Nina. Remember, we've been in 2 years of La Nina. Maybe this is just the push to get us to neutral, and our big El Nino, or some sort of a real El Nino, is still to come a year, maybe next year, maybe the year after that, maybe the year after that. And you know what? That wouldn't be bad. To have any kind of an El Nino now would not really be a good thing, because what happens? Right after you have El Nino, you go back to La Nina. We don't want to be there. So it's a good thing if we just sort of, bumble along somewhere in the slightly warm territory. And if we could do that for a couple of years, the atmosphere will respond and the jet stream will wake up. And then you could end up with maybe a couple of years of some pretty decent surf, rather than, having it all happen in 1 year and then go falling right back into a hole again of La Nina. So maybe, though this seems a bit disappointing at this juncture, maybe it's a good thing in the long run. So, with that said, the good news is, hey, there's some storms on the model. Not storms, really, gales. There's some activity in the North Pacific forecast. Maybe we'll get some swell. And we're, 6 weeks behind schedule is about typical when you're coming out of 2 years of La Nina and moving to, we'll call it a normal year. So this is not unexpected. Maybe from here on out, things will be looking a little bit better. Certainly, we have the active phase of the MJO scheduled for the next couple of weeks, and then again, maybe in the mid to late December timeframe. So, odds are there'll be some surf on the way. And regarding our El Nino, yeah, maybe it isn't going to happen. Maybe it will. Kind of hoping it actually doesn't. Maybe we just get into a neutral pattern, bias slightly warm, and that sets us up for several years. And that would be not just the winter, but also the summer of an improved jet stream pattern, and set us up for something much more favorable long term. Rather than blowing it all on one big party, we're going to spread it out over a couple of years. Maybe, just maybe, that's what's going on. Anyway, that's our hope. We'll do this again next week, same time, same channel. Thanks for watching.